Hi there, this is section 4.4, and then also it'll be the next section. This is about division of decimals. And so I just want to remind you, this problem is 31 and 48 hundredths divided by 4. And so if that's the way the problem is listed, then the 4 is outside and the 31.48 is on the inside. Now this problem, as long as this number here is a whole number, then the decimal point comes straight up. And so then let's just go ahead and see what happens. So 4 into 31 would be 7. 7 times 4 is 28. And there's 3 left over. So we would then bring down the 4. And 4 into 34 is 8. 8 times 4 is 32. There's 2 left over. And finally, bring down the 8. 4 into 28 is 7. 7 times 4 is 28. And I want you to notice the remainder is 0. Let me see if I can make it clear. So if the remainder is 0, this is an exact answer. And so there's no need for any rounding at all. So this is a good thing. So our answer would be 7 and 87 hundredths. So that's good. But sometimes when you divide, things don't stop like this one did. And so we'll have to figure out what to do about that. Sometimes decimals repeat. That's another thing that might happen. So let's say that you were asked to do this, but there's no rounding instructions. And so you're thinking, oh, well, I'm not sure what's going to happen, but it's 86 and 7/10 divided by 34. So 34 is outside and 86.7 is inside. So again, this is a problem where there's a whole number on as the divisor. And so if that's the case, we just bring this straight up, the decimal point, and start dividing. And so the fact that it didn't have rounding instructions says to me it's probably going to come out just like the previous problem, where if you go a little bit far enough, there'll be remainder 0. And so you'll have an exact answer. So that's a perfectly good answer. 34 into 86 is twice. 2 times this is 68. See if we can still do this. This is 16, subtract, it's 8. That would be 18. And I'm going to bring down the 7. 34 into 187. Okay, so now I need to think. We talked about like thinking that this is 30 so that we could make a decent guess. This is like 180. So it's like 3 into 18 is 6. I'm going to check it on the side. 34 times 6, 24, carry a 2, 18 and 2 is 20. That's a little bit too big. And so I'm going to try the 5. 5 times 4 is 20, carry a 2. 5 times 3 is 15 and 2 is 17. So that actually, at least the 5 was the correct number. So I'm going to subtract and I'm going to get 17. Now, because there were no rounding instructions and there's still a remainder, what I'm going to do is be hopeful about this, add one more 0 and bring it down. Now 34 into 170, I think is going to go. And in fact, we see it right here, what happened when we chose the 5. 5 times 34 is 170. And this gives us a remainder of 0. Now I bring this up because I had to add one more 0 for this to come out exact. So the final answer is 2 55/100ths, and there's absolutely no remainder. And so that's a lovely answer. It's an exact answer. And so we were kind of stuck when we were at this point. Well, what do we do? We're supposed to keep dividing. But there's got to be a limit to how much you have to divide. You don't divide for the rest of your life. So either there'll be rounding instructions, which will tell you exactly, where to stop, or it will come out like this one did by just going just a little bit further. So that's what I wanted you to see. We added a 0 to make that work. Now, the other type of problems for division looks like this. And instead of being a whole number, like this was, there's a decimal in the divisor. And so what we need to do is turn this into a whole number. And so moving it this way from the last class is basically multiplying by 10. Now you can't just do multiply 1 by 10 and not the other. So I'm going to have to multiply this by 10 as well. The decimal comes straight up. And so to see clearly what the problem looks like after we have created a whole number, it's 45 on the outside, 292 decimal point 5. So that's what it looks like when we've adjusted it. So at this point in time, I've got a whole number here. And so all I need to do is bring this decimal point up. So let's start dividing and see what happens. So 45 doesn't go into 29, but it should go into 292. So let's try to figure out exactly how many times that would be. I'm going to think of this maybe as 50. This is close to 30, somewhere around 6, but I'm thinking maybe 5. I don't know. I'm going to try one and see what it looks like. 5 times 5 is 25, carry a 2. This is 225. I don't think that's large enough. I should have gone with my original one. 45 times 6. This is 0, carry a 3. 6 times 4 is 24, and 3 is 27. I think that's the one we need to do, is use 6. So when I tried 5, it was too small. And so I decided to try the next one. And so 45 into 292 goes 6 times. It goes there. 6 times 45 is 270. Okay, I'm going to subtract. That's a 2, that's a 2. So that tells me this number is smaller than that number. That's the right choice. I'm going to bring down the 5. And so now my next problem is 45 into 225. And so actually the work I did over here is going to help me because it goes exactly 5 times. So I'm going to put that there. 5 times 45 happens to be 225. When you get a remainder of 0, you're done. And so that's what that is. And so I think that one worked out. We just had to shift the decimal one place at the very, very beginning. So once in a while, there are instructions about rounding. Now, this is another way to say this is not going to turn out with an exact answer. Chances are good that it's going to keep going and going, and this is going to give you a clue about where to stop your dividing. So we're dividing by 2.1, so I'm going to put that on the outside. I'm going to put this on the inside. So this is the divisor. They call this the dividend. I don't know if you need to know that, but there it is. And we have to do that same step. We have to move that decimal over in the divisor before we begin. So I'm going to bring this over one place, and I will have to match it here. so that I multiply by 10 on this number and on this number, and then this one comes up. There's my decimal point. So now, if you don't like the messy look of this, rewrite it. This is 21 divided into the decimals here. That would be 5.43. So I could copy the 0, but it's not doing me any good at this point. So there it is, 5.43. So I'm going to bring the decimal up. 21 does not go into 5, but it will go into 54. So let's try 2. 2 times 1 is 2. 2 times 2 is 4. 42. I'm going to subtract. This is a 2. This is a 1. 12 is smaller than 21. That was the right choice. I'm going to bring down the 3. 21 into 123. What do you think? 21 times 5. This is 5 and this is 10. This is 105. Here's another one where it's kind of close. 21 times 6 is 126. Notice that's too big, which means this was really, really close between a 5 or a 6. We have to choose the 5 so that it will work. 5 times 21 happens to be 105. When I subtract this, this is 18. Now, I'm told I have to round to the nearest hundredth. And so this is the 10th place and this is the 100th place. But in order to decide about rounding, I need one more number. So I need a number to make the decision about the 5. So knowing that, I really have to overshoot it or go one more place past the place where you round. So my choice is to add a 0. I'm going to bring this 0 down and I'm going to go one more round. So 21 into 180. Now it's higher than 5 and it's higher than 6. Let's try 8. 168, that looks pretty good. So how did I decide what to do? Well, I rounded this to 20 and this was already 180. And so it's like 2 into 18, which would have been 9. But the truth of the matter is 9 is just a little bit too big. It's 189. And that's why I'm going to have to go with the 8. I'm going to put it 8. 8 times 1 is 8. And 8 times 2 is 16. And when I subtract, it's 12. But the question is, do I keep dividing forever and ever? And the answer is no. Because I go back to the rounding instructions. I'm going to round to the nearest hundredth, tenths, hundredths. So here's my answer, 0.258. I need to round to the hundredth place. Once I knew this was a large number, 5 or more, I knew what had to happen here. And so the 5 needs to go to 6. So that's my final answer. Rounded to the nearest hundred, it is 0.26. Any more division won't change anything. It's the 8 that determines what happens to the 5. And so when the 8 was large, the 5 went to 6. And so they wanted rounded to the 100th place. So you don't put any more numbers after the 100th place. Tenths, hundredths, that's it, okay? Now, one of the things they have us do, this is the next section. And one of the things they have us do is go back and forth between fractions and decimals. So at this point in time, we should have a fairly good idea how to proceed. Now, look to see what the problem is. This is a fraction. So if they're going to ask you to do something, chances are they'll ask you to make it a decimal, not a fraction anymore. And so this requires dividing. Now, here's the problem. Some people think, I'm going to make my division problem, but I'll put the small number on the outside because it would be so much easier that way. Well, that's not what this is asking you to do. This is 14 divided by 25, which means the 25 is on the outside. And the 14 is on the inside. Now, if you look at that, you're saying, oh, I can't do that. Well, once we have decimals, we can do it, because what we'll do is we know there's a decimal point after the 14. It's a whole number, so the decimal is to the right. And I'm going to add 1, maybe 2 zeros and see if I can't divide this out. Now, let me divide it, and then I'm going to show you one other thing. So 25 did not go into 14. We realize that. But 25 will go into 140. And if you think of money, this is quarters, and this is $1.40. How many quarters would you have? Well, you would have 4 for the first dollar and another one, and then that would be 5. So I don't know if that helps, but 5 quarters, 5 times 5 is 25, carry a 2. 5 times 2 is 10, and 2 is 12. When I subtract 125 from 140, the answer is 15. That was correct because that's smaller than 25. I'm going to bring down, oh yes, this is turning out good. 25 into 150. How many quarters in $1.50? The answer, of course, is 6. 6 times 5 is 30, carrier 3. Whenever you get a division problem where there's 0 remainder, this is good. And so there's no need for anybody to say something about rounding. And when they don't say anything about rounding, you are kind of expecting it to terminate. In other words, there would be 0 remainder somewhere along the line. So this particular one, 0.56. That would be your answer. Now, I just thought of something. So let's take a look at this original problem, 14 over 25. And the problem where people want to write their division problem, but they get the 2 backwards. So here's a technique that will help you always get the right number on the outside and the wrong number, whatever. And so here's a little trick. So I'm going to turn this fraction into a division. And so the 14 comes down. The 25 stays where it was. And so this problem becomes 25 into 14. Now, you didn't want it that way, but that's the way it should be. And so knowing that this is all about decimals, that's the point where I added a couple of zeros to make this work, because 25 into 14 wouldn't have done it at all. So this little thing, I don't know, I do it all the time. Just make the fraction into a division problem. Then if you don't like the mess of this, rewrite it nice, and then do that problem, and then you'll know you've got it. Okay. So this particular problem, it says, here's a fraction, write it as a decimal, and they want it to the 100th place. Now, whenever they say that, there's a good chance that this is not going to stop and have a nice 0 remainder. It may be that it's just going to keep going. And so thankfully, they tell us exactly where, how far out we have to go. And 100th place is 2 decimals, the 10th and the 100th. but we're going to have to go 3 to be sure we have a number to make the decision about rounding. So I'm going to try this. I'm going to turn this in to a division problem. I'm going to bring the 3 down. And that's the actual problem. It's 28 divided into 3. Well, that's not going to work unless I add some zeros. And because it said hundredth place, that's tenths, that's a hundredths. I'm going to go one more because I really need that extra place to make the decision about rounding. So it's 28 divided into 3. And so this is a whole number, so that part's good. The decimal just comes straight up. And so the first thing I'm going to do is 28 into 30. That does go once. 1 times 28 is 28. Subtract. Oh, this is a good one. Bring down. This happens and people get all tangled because they don't know what to do. You subtracted, you had 2. You brought down like you were supposed to, and then you're supposed to divide. 28 does not divide into 20. When that happens, you put a 0 here, and you then bring down the next number. Now we've got something that will work. 28 into 200. So this is about 30, and this is about 20. 200, so 3 into 20, it's going to be about 6. Let's see, 7 maybe. Let's try 7. 7 times 6 is 56, carrier 5. This is 14 and 196. That is the correct answer. 28 times 7. So 7 times 28, if I'm still doing this correctly, is 196, and you subtract. But do we have to go any further? The answer is I can stop right this minute, because not only do I have the tenths and the hundredths, but I have that one extra number to make a decision about rounding. So here's what I have. 107, okay? And the rounding is to the hundredths place. So all I have to do is look at the 7. And the 7 is large. So the 0 becomes the next number, which is 1. This is the number rounded to the hundredths place. And so I'm glad we got one with 0 because that confuses people. Okay. The other way to do this is 3 divided by 28. You immediately put the 28 on the outside, but this little trick, it may help a few, I don't know, but I do think it's fairly good. This one here, now we're going to go the other way. Now we have a decimal, clearly. I have 2 of them actually, and I want to make it a fraction. And in order to do that, I have to be able to read it properly. This is tenths, this is a hundredths. So this is, as a fraction, 45 100ths. Well, you know as well as I do that they don't like things that aren't reduced. They want the simplest answer humanly possible. This is not it. But we can divide it out a little bit, and we say, well, what number would divide both of these to cut this down to the simplest fraction? And the answer, of course, is 5. 5 into 45 would be 9. And 5 into 100, 5 into 10 is 2. 5 into 0 is 0. So this reduces from 45 over 100 to 9 over 20. Then you say, okay, could this reduce any more? And the answer is no. 9 is 3 times 3. There are no 3s as a factor in 20. This is done. Okay, so that's what they wanted. It was a decimal. we wanted a fraction. So I wanted to try something that's a little bit higher in terms. Tenths, hundreds, thousands. This is 375 1,000ths. Well, that's kind of a large number, but we're going for a fraction, and so we made it a fraction, but now we need to reduce it. You could reduce it by 5. Or if you're brave, you could reduce it by 25. I'm not sure which way you want to go. To reduce it by 25, you have to think of quarters. And so how many quarters in 375? Well, the first $3 would have 4, 4, 4. That would be 12. And then 3 more would be 13, 14, 15. So that would be 15. And then 25 into 100 is 40. This is not fully reduced, but that took it down to size. Now, let's say that little game of quarters did not appeal to you. You could still go by 5. So 5 into 37 is 7, 2 left over. 5 into 25 is 5. And then 5 into 1,000, 5 into 10 is 2, with 2 extra zeros. So if that's our case, we could either divide by 5 again, or we could, at this point feel like we could divide by 25. Either way, both of these answers are going to come out the same. I'm going to keep dividing by 5 on this one in case that seems to be the only way. 5 into 75, 5 into 7 is 1, 15. 5 into this is 40. They're now at the same level, but we're not done. And so regardless of how you tackle this problem, we still need to divide by 5 again. So 5 into 15 is 3, 5 into 40 is 8. They would both turn out 8, whether you got there sooner or later. That would be your final answer. And so nothing in between was simplified. And so they wanted the 3/8. They didn't want any of these others. Although this was a good first step. This was a good first step, but you needed to take it down even further. Now, there's a couple more little sections, and so I'm going to proceed with this. This is a decimal, and they want a mixed number, basically a whole number and a fraction. And so this would have to be 1. This is tenths. This is hundredths. 1 and 22 hundredths. Well, the 1's good, but the 22 over 100 needs to be reduced. And the only thing I can think of is to reduce it by a 2. So I'm going to copy the 1 just to get it done. But dividing this by 2, 2 into 22 is 11, and 2 into 100 is 50. 11 is prime. There are no 11s as factors of 50. This is the end of the road for that one. That's as simple as we can get it. This is just another example. This is 5 tenths, hundredths. This is 6 over 100. So 6 over 100, the only thing that really divides it is 2 again. So 2 into 6 is 3, and 2 into this is 50. Those are similar problems. And that one's done. So it's a matter, are you given the decimal and they want a fraction, or in this case, a mixed number? Or the reverse, are you given a fraction, like this one? They're given a fraction and they'd like you to give it as a decimal. But it becomes useful to know how to go back and forth with these problems, because sometimes one is easier to do than the other. Now, I think the last part of this section, I think this is 4, I don't know, 4 or 5 maybe, This last section is about simplifying problems that have both fractions and decimals in them. So when you see that, there's typically a better way to go. In other words, make it decimals because that would be good, or sometimes fractions are easier to work with. But let's look carefully before we begin and go too far and see the instructions. The answer is supposed to be a decimal. So if they expect a decimal out of this, I think we should convert things to decimals. Now, the good part is this is order of operation. We need to add this first, and so that's not an issue. 1.8, 7.6, 14, carry a 1. This looks like a 9. So in parentheses is 9.4. But because they expected it to be a decimal, this probably is our best plan, is to convert this fraction to a decimal and then do the last computation. So you may know that the decimal version of 3/4, in fact, the ones that you know fairly well, you don't have to do. But let's say you didn't know this one. This is 3 divided by 4. The decimal comes up. 4 into 30 is 7. And 4 into 20 is 5. So the decimal version of 3/4 is 0.75. If you look closely at the original problem, there was nothing in between here. And so you have to assume it's multiply. The parentheses tell you so. The fact that there was nothing here tells you so. And so at this point in time, we're back to the other section. And so I think I'm going to do it 9.4 multiplied by 0.75. So this is review. 5 times 4 is 20. Carry a 2. 9 times 5 is 45, and 2 is 47. I'm going to do this last bit. 7 times 4 is 28. Carry a 2. 7 times 9 is 63, and 2 is 65. 0. 5, carry a 1. I'm getting tired. 0, 15. I guess that's good. So now this is multiply. This is where you actually count the number of decimal places and then put it into your answer. So this is 1, this is 2, this is 3. So our final answer is 7.050. All right. So we did the work. We added the decimals. We turned 3/4 into 0.75. We then multiplied and we got this answer, which written nicely is this answer. So the question is, what do we do about this 0? This is sometimes referred to as a trailing 0. It's added to the decimal, and so we don't really need it. So I tried some of the problems, and I wanted to see what happened when you left the 0 on and XYZ didn't, mark you wrong. But this is the better answer without that extra 0. So I would prefer you try this one and let go of extra stuff that you don't really need that doesn't change it one bit. So that's your answer. 7 and 5/100. I think there's 1 or 2 more. This struck me as odd and I wanted you to see it. We want this as a decimal. Wow, I just thought of a different way to do this. This is a decimal, this is not, but you may know that 1/2 is 0.5. I think that's probably the straightforward way. They want a decimal, let's work with decimals. And so this is a matter of dividing it out. Now this, you're dividing by 0.5, and so that's on the outside, right? So this, what we need to do is make sure we're dividing by a whole number, which means a decimal shift of multiplying by 10, one place, and then a match here. And at that point in time, bring your decimal up before you forget. So this is actually the number 5 into 19.9. So it's up to you whether this is too messy and you want it nice and clean, and then the decimal comes up. We should be able to do this now because this is a simple thing to finish. 5 into 19 goes 3. This is 15. That's a 4. I'm going to bring down the 9, and I'm hoping this is going to turn out. Okay, 5 into 49 is 9. 9 times 5 is 45. Oh, there you go. See, I started to panic, but the truth of the matter is there were no instructions in the original problem. Then I'm thinking, well, it probably should give me a 0 remainder soon enough if I just have patience. And so 49 take away 45 is 4. I'm going to add one more 0 to the mix, and I've got it. 5 into 40 is 8. 8 times 5 is 40. Remainder 0. Okay. So there's our answer, 3.98, or 3 98/100. Okay. So it looked bad. And there was another way to do it, but the minute I thought about it, make it a decimal straight off the bat and then do the division. That actually made the most sense. Although things that work make sense too. Here's, there's a few more like this. And so the decision about what to do has to do with what they want for a final answer. And so it's not like they're asking you to figure it out. They just basically want a decimal answer. So this is a fraction, this is a fraction. And so we might just consider turning this whole problem into a fraction problem, and then proceed from there. 7 divided by 8, I'm going to do it. I'm going to make it a division problem. It does terminate. It sounds funny. 8 into 70. It's not 9, it's 8. 8 times 8 is 64. I'm going to subtract and bring down. 8 into 60 is 7. 56. And I'm going to have to add one more 0 to make this fly. When I subtract, I get 4. I bring down that last 0. 8 into 40 is 5, and that's it. So this 7 divided by 8 is really 0.875. Okay, this is a decimal already, so I'm going to leave it. And hopefully some of these 3/4 is 0.75. So although we haven't completed the problem, I've turned everything into decimals, and I think that's probably going to be my best bet. This is order of operation. Adding is last, multiplying would be next. So I'm going to go 0.45 times 0.75 and see what this is. It's going to be a little bit large. This is 25 carry a 2. This is 20 and 2 is 22. And I probably am going fast on this multiplication. And so I'll try to slow down, but basically I think 7 times 5 is 35 and 7 times 4 is 28 and 3 is 31. That's a 5, that's a 7, that's a 3, and that's a 3. So now what I do is I count my decimal places. I've got 1, 2, 3, 4, a total of 4. It's way at the front. So this times this is 0.3375. That's done. This one, we divide it out. And the very last thing we do is to add the result of this as a decimal and this from our computation. So let me see if I can find a paper that would do this for us. I'm going to put this one first. It doesn't matter. Okay. So there's a 0 here and a 0 here. I can add a 0 at the very end just to make things squared off, or I could have left it, but I am going to add, and everything is lined up properly. So this is a 5. This is 12, carry a 1. This is 10 and 1 is 11, carry a 1. This is 11 and 1 is 12. So let's go back to the original problem. They wanted the answer as a decimal. Here it is. How is that? Okay, so let's look and see what actually I did. I divided out 7/8, and it's a nice decimal, and so I did it, and there it was. We did it by division. 3/4 became 0.75. We multiplied them and it became that. And finally, this number and that number had to be added to give the final answer, and that was it. Let's see if we're homing in on this. There's a few problems here where they're using the word find the sum of these two numbers, and they want it as a fraction. So if that's the case, this is a fraction, but this isn't. So if you remember from just a second ago, 0.75 is actually 3/4. And 1/3 is perfectly good. And what they actually want you to do is add those two. Now, many people find that if you put them vertically, you could get that common denominator 12, and then you can finish that problem. So that would be, let me quickly do it, 1/3 and 3/4. We're going to make them both 12 equals 12. This top one needs to be multiplied by 4 to get it to 12. 3 times 4 is 12. 1 times 4 is 4. And then this 4 needs a 3. 4 times 3 is 12. 3 times 3 is 9. So when we put this together, 4 and 9 make 13 over 12. 13/12. You know, typically they expect the mixed numbers, so they seem, at this point, they seem to favor it. So let's just give them what they typically want. Okay. So that was my thing. And this one here, of course, is the last one. Find the product. Now let's go back to the instructions. They wanted a fraction. And so this is 3/2 multiplied by 1.5. Well, I started to say it. This is 1.5, isn't it? And so 1.5, if I'm going to multiply, you basically do this. 2 times 1 is 2, and 1 is 3. So that's 3/2 as well. So it's 3/2 multiplied by 1.5, which is also 3/2. Why did I make this a fraction? Because they wanted the answer as a fraction. There's nothing to cancel here, so I'm just going to multiply across 9/4. Again, making a mixed number since typically they want it. 4 into 9 is twice with 1 left over. And so I'm suspecting that would be what they'd want. Okay. So that's where I'm going to stop. See what you can do. If you have trouble, use late pass. And I won't be there on Wednesday, but I will see you on Friday. So good luck, and hopefully this works out.